Okay, so welcome back. So today is going to be midterm test. Okay, so today we have so the schedule is going to be like this. Okay, we get 1 to 3, get 3 questions. Okay, so all the questions coming from our slide. So before we start, I'm going to quickly make a revisions. Roughly what's going to be examined in this midterm test. Okay, so before we start, I maybe spend maybe 20 minutes to help you to review because today is close book. Okay. Okay, before I start, I still want to emphasize the teaching plan. So by next week, okay, I'm going to provide the topics. It means you get 3 weeks to prepare the case study presentation. So we get 1 to 3 weeks for the teaching. So the 2 weeks for the presentation. So each of you requires to make a presentation because we get 11 students in this lecture. Okay. So any questions for the teaching plan? It's clear? Okay. So yeah, feel free to relax. Today is only 3 questions. I'm quite sure that you can finish your midterm test like maybe 1.5 hours. Yeah, it's quite easy actually. So let's make a quick revisions on the content we had delivered in the past weeks. Okay, so for example, in the first week, okay, we're talking about the fundamental concepts for the navigations, right? So like we talk about the basic sensors for the like smartphones. If you have a bunch of sensors in your smartphones, and the palm positioning and directioning. So directioning means you try to calculate your position by doing the relative position accumulation. So this is the TDOA, time differences. So it means okay, so we get 2 signal transmitters. Okay, for example, this is the transmitter. You want to get to the location. So the range is a known variable. So this is based on the time differences multiply the speed of light. So finally you get this range and the position is known variables. You try to estimate the location of a receiver based on the 2 equations. So this is a range based. Okay, so this is about the basic concepts for the Wi-Fi RTT. So for the Wi-Fi RTT, we get 2 different solutions. 2 different typical solutions for positioning. The first one is fingerprinting. So by matching the signal strengths. So second one is based on range. For example, you can calculate based on, for example, this is a router. You can calculate the time differences, multiply the speed of light, you get to the distance. So because the router's location is known variable, so you can calculate your location based on the 3 measurements. And the second, okay, the next part is about AOA. So for example, if the measurement is not a range, so the measurement is an angle, okay, the angle, and the position of the receiver is known variables. So how to calculate the location of this one? So this is the examples, okay? You can get this equations, blah, blah, you can finally get this matrix. So you can do the inverse. So for example, okay. So for example, like tangent 45 degrees. Okay, this is equal to 1, right? Another information is the tangent 30 degrees equivalent to. Okay, so have you take your calculators? Calculators already, right? That's great. So for example, if the question is like, okay, this is transmitter 1, transmitter 2. Okay, for example, this position is x1, x2, y2. So if this angle is theta, this angle is theta 2. Okay. So typically, you want to estimate the position of xy. So based on this basic physical models, you should be able to, like, this is y, this is, get to first based on the data, you get to the measurement equation. Theta 1 should be equal to okay, and based on this measurement, you should be able to get to the so in this case, you can write those two equations into a matrix. Okay, so for example, you can write down this to the left side. Okay, for example, so the similar, you can write down like these two equations into a matrix. Okay. Okay, so in this equations, the only unknown is x and y. And for example, this is A matrix, this is X, this is B. So in this case, X should be equivalent to A inverse multiply B, okay? So, okay, provided this part, okay? Erase everything here, okay? Except for this one, okay? So for matrix A, B, for example, this is a matrix 2 by 2. If you calculate the inverse, this should be equivalent to AD minus BC, okay, over 1 multiply EA. Okay, let's change the position. Minus. Okay, so this is a solution. So for example, calculate the inverse for this one, okay? 2 by 2 matrix. This is 2 by 1, okay? This is a 2 by 1 matrix. So you need to calculate the inverse, okay? So in this case, if you have one numbers like if this is 45 degree, this is 30 degree, of course, like if this is 3 meters, 4 meters, you can calculate xy. Okay, so in the practice, you may have received signal from multiple receivers. Okay, one more receivers. Okay, so in this case, you cannot solve it directly using manual calculations, right? This can be done by computers, but no worries. I mean, in the exam, we only provide the questions with 2 transmitters. Okay, so another one is okay. It's good. You're good. Okay. So next question is going to be about the, it's a fitting problem, like for example, like GPS. Okay, so we're talking about the linear least square problem for solving the GPS single pole positions, right? So from this one, I introduce the line fitting problem. So for example, I give you a series of points. This is Y. This is X, right? So for example, I provide a series point here, okay? So this is extreme cases, you have a lot of points, a bunch of points. So fitting of curve, okay, this is Ax plus By plus C equals to 1. So this is a function 1 to fitting. So A and B and okay, this is unknown variables, right? This is unknown variables. So you know it's a series points like x1. Okay, for example, this is P1, P2, x2, y2, pn. Okay, it's going to be xn. Page 8. Okay, so how to find out the basic fitting? So if we look into, okay, if I provide like 1, 2, 3, 4, 5 points, okay, so the basic curve may be some kind of like this, okay. Okay, we get 5 points. So we have two. I mean, if you want to find the basic line to fit in all those points, so we have different methods to evaluate the distance from the point to line. The first one is like it's called vertical. Okay, vertical offset. Okay, let's see the vertical offset. We want to minimize the summations of those distances. So, for example, this is P2, P3, P4, P5. Okay, so distance from this, okay, from P1, okay, this I mean the distance of this is equivalent to, like, for example, like if we define the distance for this one is like, okay, if the distance denoted by r from P1 should be equivalent to minus, for example, okay, you can put this line. So y should be equal to a x times kind of like this, right? So distance should be minus a bx minus. So this is so-called the vertical distance. So this is also called the residual, okay? It's the same physical meaning. So if you evaluate the distance with the, I mean, another solution is the vertical distance or the perpendicular distance. So the distance is going to be calculated like, should be is that correct? So let's say a distance, right? So it's a typical cases. But that is the typical cases to be, I mean, yeah, in practice, if you want to fit a lot based on all those points, so this distance is usually, I mean, used. I mean, this is going to be more accurate because this is square known distance. So if you want to, I mean, if you want to find base A and B and C, right? Is that correct? If you can determine the 3 parameters, you are able to determine the lines. So to get the, okay, it's going to be like problems like you want to minimize the summation of, for example, I means the index of the point. If you have 10 points, you minimize the distance, this perpendicular distance, and minimize the summation of all those distances, right? This is going to be equivalent to minimize from all points, okay, summation of all the distance. This is going to be a square plus b square root and a x I plus b y I plus c. Okay, something like this. You want to minimize this. So as we mentioned in the lecture slide, okay, go back to the lecture slide last week. Okay, so to minimize this, we need to going to be slightly different in the lecture slide because in lecture slide assume the function is y equals to ax plus b. So this equation is going to be slightly different, but it's the equivalent. So if you want to minimize this distance, the summation of this distance, okay, minimize the summation of this distance, you need to the differential. Okay, for example, like the optimal points are usually located at the point with the zero gradients, right? So you can calculate the partial differential to make sure the partial differential is approaching zero. So in this case, you need to calculate the partial differential for, like, for example, calculate the partial differential. You need to calculate the partial differential for A, right? And also calculate the partial differential for B. Okay, this is the same. And for this equation, okay, you see, this equation is can be like, so if you want to calculate the partial differential for fx over gx, okay, so if you want to calculate the partial differential for this one, okay, it's equivalent to minus fx g partial differential x. So this is from first year, right? So for a partial differential, so in this case, you can calculate the partial differential for this one. Sorry, it's a square. Okay. Okay, it's a square. So let me try an example. Okay, so for example, if you want to calculate the partial differential for b, okay, it means you want to calculate the partial differential of a square plus b square ax I yi plus c square because there is a square over there. So partial differential for b. This is going to equivalent to, you want to calculate the partial differential of a x I plus b y I plus c square of a square plus b square. Okay, of this partial differential. So this is gx, this is fx. So by putting into this equation, you can solve the partial differential. So in the example, you don't need to really calculate the, I mean, you can calculate this partial differential is good enough, okay? So, any questions? For example, this one, we have two different distance evaluation. So the first one is the vertical. So the second one is the perpendicular, okay? So for the, it's quite straightforward. yi minus the predicted y. So, and for the perpendicular distance, this is going to be like this. So, so yeah, so we need to calculate the summation of this distance because to find ABC, okay, the parameters, we need to minimize the distance from the point to line. So in this case, as we mentioned, okay, the point, optimal points usually with the zero gradients. So we need to calculate the gradients. Okay, calculate the gradients, calculate the partial differential. Okay, calculate this partial differential. Stop here is good enough. Okay, I mean you need to calculate the partial differential and the stop is good enough. Any questions? 2 more seconds. 1, 2, 3. No. So three finish. Okay, I mean maybe 2.5. So if you can finish in advance, I'm quite sure you can finish in advance. Okay, so just feel free to submit. Okay, so one question paper together with 10 white papers for you to write down your answers. Okay. Let's please. And write down the number ID and write down your student's name. So please be noted close book, okay? Close book means you can not use your smartphone. So we have 3 TAs here. If you want to in the front, two in the back. So if okay, for example, okay, if you didn't take your calculators, okay, you can use this variables. 10 to 45 degrees, 10 to 30 degrees. And for the so for example, if examples like this. Student name and student ID, okay? Okay, so your attention, please. So for the last question, the last question C and D. Okay, so in here we need to calculate the partial differential for A and B, right? So you can, you can define. So the A and B is corresponding to the, for example, if you get it's like a linear line function, you can define like A by plus C0, right? So A and B is this one, okay? Also, you can define like y equals to ax plus b. Okay, you can define a line equation, or you can represent a line equation with this is okay. This one is also okay, okay? Also is okay. Because in the last question we mainly wish to evaluate your understanding of the partial differential. Okay, you can use this representation or this representation. Both are okay.